Eric Darling here with Darling Data, and in this video we're going to continue our rhapsody on store procedures, and in this one we're going to talk a bit about how the data types. Okay, data types. That's what we're going to talk about in this one, because I see a lot of people screw a lot of stuff up with these. And is the person who comes in well after these screw-ups have been in place and occurring for a very long time, who has to clean them up. It's a terribly unpleasant task. Sometimes it is a little bit easier, because sometimes there will just be a problem with whatever parameter was being passed to the store procedure. Other times there's a problem with the underlying table data types, and at this point the tables have grown quite large, and sure, you have options like creating computed columns that do data type conversions for you, but you still really do need to index those computed columns. So even if you get the sort of lock-free add a non-persisted computed column thing to your table that does your try cast, try convert, try parse, whatever to your column to a different data type, to a more correct data type, you still incur that sort of locking, well, potentially locking. If you're on standard edition, you're definitely locking. But in either case, size of data index creation operation to create an index that now helps your query use that computed column in a efficient way. So we're going to talk about some of this stuff today, and just some of the ways that you can get around the more basic common problems with incorrectly typed stuff in your store procedures. Before we do that, we should talk about how cool I am, and how you should give me $4 a month. How you can click a link in the video description to do that. If you think I'm cooler than $4 a month, you can give me more than $4 a month. But I think $4 a month is like my entry-level cool purchase, and that all goes towards supporting the channel in general, making sure that Bats here stays full of delicious Pez, and that I can pop a Pez and have the energy to carry on creating this content. If you disagree with Pez, or if you just hate Bats, you can do other stuff. You can like, you can comment, you can subscribe, and if you want to ask reasonable questions that I will answer on an office hours episode, the link to do that is down in the video description as well. And if you are out there struggling with a ill-performing SQL Server and you need help at a reasonable rate, well, I've got nothing but reasonable rates, and you can hire me to do any of this stuff, which is a pretty reasonable set of stuff at a reasonable rate. So we've got all this going for us. If you would like some training content about SQL Server performance tuning, I've got beginner, intermediate, and expert level stuff. Really some noodle baking activities here, and you can get all of mine for about 150 USD for the rest of your life. Long live you. Fully assembled link for that is, of course, in the video description as well. If you would like to see, well, I mean, I will be there in person. I'm not presenting anything unless someone gets sick or dies or doesn't show up. Then I'll fill in a session. But if you would like to come hang out and have me give you a bag of lunch, you can come to SQL Saturday, New York City, 2025, taking place on May the 10th, with a performance tuning pre-con by Andreas Volta on May the 9th. May the 9th. I don't know where November came from. November is not involved with this. So we have that going for us. But with that out of the way, let's talk a little bit about data types and store procedures. Now, I see a lot of people screw up a lot of stuff. Mismatching DateTime 2 stuff is a big one. That's going to be the first thing that we talk about, because there are actually some like weird bugs, and some of them depend on, well, the one that I'm going to show you does depend on compatibility level, but whatever. Of course, mismatching string data types, varchar versus varchar, right? Because they're, well, I guess varchar and varchar. I just have a hard time with the var, even though I'm pretty harsh on the char there. Character and variable character, whatever. I don't want to sound southern. No offense to the southern folks, I just don't want to appropriate your accent in an unfortunate manner. But then, like, you just see absolute boneheaded stuff like this, where people have two tables, and they're like, oh, eventually I'm going to join these two tables together on this column and this column. But for some reason, even though both columns will have commensurate data in them, one of them is like a varchar 255 and the other is an integer, and you're like, how'd that happen? Lots of shrugs, and they're like, is that a big deal? And you're like, yeah, suppose it is. Since we're talking, suppose it is a big deal. Anyway, let's move on. So this demo comes from a question that got asked a little while back on dba.stackexchange.com, and it's something about why DateTime value return that matches the predicate something. There's a lot of words in there, kind of a noodle bash in that one. And then that ended up with the fellow who answered it, Martin Smith, brilliant fellow, creating a feedback item. If I remember, the links will be in the video description. If I don't, sorry. But if you run through this demo, it's a very strange one, and you might want to read the question and the bug report, because they do add some more detail in there. But the general gist of this is that we declare a variable called dt, which is a date time, and we set that equal to something. And then we declare a variable called dt2, which is a date time 2, and we set that equal to the date time parameter. Then we insert the date time local variable into a table variable with a primary key on it. And when we ask if dt equals dt2, right, coming from the table, or if we say where cast dt2 as date time, which it already is a date time, like here and here, equals dt2, then we get some strange results back, right? And if you go and you read through, right, like that doesn't make any sense. But what's really weird is if you go and you read through the feedback item, there is a comment in there by Sir Pablo Blanco, where he says if you take the index out entirely, right? So let's just delete where it says primary key. Look what happens now. All right, now neither one returns any rows, right? With the primary key thing in there, we did return a row from one of them, but without the primary key, we lose that. So I think Microsoft does potentially have some work to do here, because that is a strange result. So be really careful with the date and date time stuff. But there are generally a few data types that will always make me nervous when I see them, either as a parameter or a variable or a column data type. That will be max strings. That goes for any variety of string that is a max data type. Except for when you're using it for dynamic SQL, then I am a-okay with it. XML, always nerve-wracking. JSON apparently is a data type in Azure SQL DB, which is really just a synonym for varchar max anyway, so, but let's not say too much. But XML has been making me nervous for years. Also annoying me, because now I'm like, great, I'm gonna have to write more XQuery. Now I'm gonna have to go look at all the XQuery I've ever written to make sure I'm doing it right. And of course, SQL variant is another scary one to see, because you just don't know what you're gonna get. I just expect something bad to happen whenever I see any of this stuff show up in the words I see in SQL Server Management Studio. Another thing that is very common that gets screwed up is ORM data typing. I wish I knew what this pattern looked like in Entity Framework, but when people don't strongly type whatever arguments they're feeding to their Entity Framework queries, they can end up as all varchar 8000 or nvarchar 4000 or maxes. Or sometimes what'll happen is Entity Framework will at runtime infer the nature of the string. Usually it will like default to Unicode because Unicode is like more safe. Like you don't like just for, like in the sense that you're not going to lose fidelity if you use Unicode. Like if someone actually has a Unicode character in there and you don't use a Unicode string type or parameter type, you will end up with like question marks or like blank spaces or empty boxes or something. So they all usually use like infer that some string is going to be a Unicode thing, but then it will infer the length of the parameter based on the length of whatever you pass in. So if you had the same query running without strongly typed parameters, and you passed in like a variety of different arguments, you would end up with a variety of different like entries in the plan cache and query store with all different parameter lengths in them. So like if you said like where some name equals Eric, you'd end up with an in varchar 4, Kendra would be in varchar 5, Tom would be in varchar 3, Al would be in varchar 2, and if you were trying to find Q Lazarus, you would end up with an in varchar 1, and that was like you would just end up with different, like, I mean, even if it was the same plan, it would be different plan cache and query store entries for the same query with different plans across all of them. So that's not very fun at all. Now, another thing that I will see people do quite a bit is when they are trying to have, their, like, you can search anything with this store procedure. And it ends up, being something like this where they never know what this is going to be. And in some cases, like within the context of Stack Overflow, like the body column is in varchar max. Like even though I think internally, like Stack Overflow sets a character limit on this, like 30,000 or 50,000 or something like that. Like this is what you get. Like it's still like declared like or defined in the table as in varchar max. So what I see a lot of people do is just have like, their universal search string, and they'll stick some parentheses around it, and then they'll use that to search across a variety of columns with a variety of data types. Some of them, like these three, might be strings. Then some of them might be dates, like the ones that say date in the name. And some of them might be numbers, like the ones that say ID in the name. And this is just a whole host of problems that you don't want to deal with. You're, of course, in these cases, much better off defining having actual search parameters for each one, like not doing this, like just having a parameter for each one of these. What you want to avoid, unless you are okay with like a recompile hint, is doing something like this with it, right? Like this has lots of problems in SQL Server. SQL Server 2025 is sort of maybe supposed to give you some help with this. We'll see how it goes. I haven't seen how that all works yet, so I can't say anything. But if you want to write like this kind of search procedure in a way that doesn't suck, I have a whole video presentation. It's a talk that I do on defeating parameter sniffing with dynamic SQL, which gives you all sorts of ways to write these queries in a way that will perform well across a variety of execution. So that's nice. Another big anti-pattern that I see is people passing in lists of things, right? Usually comma-separated lists. Now, table-valued parameters can be a good option to get around this, but table-valued parameters unfortunately are backed by table variables and have their own sort of weird set of issues that you might see there. So you might need a temp table even if you're already in a store procedure, even if you're already passing a table-valued parameter to it, so that you can get statistics generated on your temp table and get like better performance when you join that thing off to other things. If you're not using your table value parameter in a way where performance is critical, or where you get okay performance anyway, don't worry about it. But if you're ever using table value parameters and you're finding the query performance behavior a little weird and hard to predict, you might want to start dumping the contents of your table value parameter into a temp table. So a big anti-pattern is to do something like this though, right? Like let's say you have your search string, and let's say this is a CSV list of like IDs, right? And you do something like this, and you say, well, I'm just going to say where p.id is in when I split this out. And this goes for like any kind of like string dissection method. The most evil person in the world who contributes to the entity framework Microsoft stuff just tried to like fix a problem with in clauses like this with JSON and JSON string splitting, and I've just had like a bunch of my clients have been like, oh, EF core, it's so great, but then they get to this JSON thing and it's like, why do these queries all take 3 minutes now? Why do these queries suddenly take 15 minutes to run? Well, it's because of the JSON parsing. Like SQL Server doesn't have statistics on what the contents of this string are. Even if there's one thing in this string, even if there's one thing, doesn't matter. Right? SQL Server has no idea what's in it. Right? It does not take every value out and do cardinality for each value. It's a complete black box for it. So like, don't do this. This is a bad idea. That's why this is anti-pattern up here. Right? This is not good. A much better idea, like I was saying, is a good alternative if you're having problems with table valued parameters, would be to do something like this, where you create a temp table with the correct data type for whatever data you're putting into it, right? Like you can even, index that temp table in a useful way, and you can do things to protect your query from having like the contents of your temp table from having problems, right? So like what I end up doing a lot is something like this, where and I'm not like for like obviously like select distinct on like big results with lots of columns in them would be like a nasty performance hit in some cases. But on something like this, where I'm pulling a list of values out of a string, I'm not worried about distinct for this. This is fine. But what I want to do is make sure that I'm respecting the uniqueness of the primary key with distinct, and that I am not doing anything that might result in an error. So like, let's say like there's something malformed in the string and something gets messed up, and you end up with like the letter A as one of the CSV values. This would obviously mess up if you try to insert the letter A into an integer column. So I always do try cast, and I use try cast instead of try convert here, because try convert is compatibility level sensitive, where try cast you can use anywhere. And then I also stick a where clause on there. And now, granted, if I saw, this is another one of those things where like if I saw this in like a real query, like with try cast wrapped around the column in a table, I'd obviously we have to talk about this a little bit, but in this case, just like the distinct, because I'm just pulling a list of a list of values out of a CSV string with the built-in string split function, this isn't going to be a big performance hit. Even if you had a lot of stuff in there, this wouldn't be that big a deal. But once all that data is in that temp table with the correct data type and with a good useful index on it, stuff like this starts performing way, way better. So we do have this is a much better pattern for the CSV thing. Another really unfortunate anti-pattern is it's important. What's important here is that if the base table column data type is in varchar max, you're going to see this behavior no matter what, because SQL Server runs into the same problem whether a parameter or variable data type is max or whether the base column data type is max. And that problem is that you can't push those predicates down far enough into the query plan all the time. Even if you have a good index, you can only partially seek to some of the values. You're still going to see a late filter operator in the query plan. But if I run both of these, even with a recompile hint on them, where SQL Server should be able to say, hey, you know what, I think something's weird here. I think this in varchar max isn't necessary, because we don't actually have a max data, like a max being passed into this. The query plans for both of these are just about identical, right, across the board. They both have these filter operators in them, right? So we pull all the things out of the clustered index, like all the rows out of the clustered index, all 17 million of them, and then we filter them down over here, right? And like even with the recompile hint, where we see the literal value, SQL Server has to apply that after the fact, and that's no good at all. So without the recompile hint, you would see the same thing. The recompile hint doesn't help here. What you want to do instead is use the right, make sure that you're not using a max. If you could use in varchar 4000 here, and it would be fine because it's not a max. But what you want to make sure is that you are as much as and often as you can using the exact right data type for both of these. Now, this isn't going to have a profound performance difference because we don't have a good supporting index on the post table to search by title. But notice for this one, we can, like, at least we don't have that filter happening afterwards, right? We're gonna if we look at this one where it's parameterized, like we can at least apply the predicate while we're reading through data pages. We don't have to pull out all the data pages and then filter them later. If we had an index on the title column, we could do some other stuff. And kind of coming back to like some of the stupidity of the Stack Overflow database, like we could also do some stuff with like post type ID, since like both questions and answers are in the post table. There's not like a post questions and post answers tables like that has them separate. Like there's a post type ID column, and only post type IDs of 1 will have a non-null title. So like you could even do some stuff with like indexing, and like instead of would probably be a good idea if you're searching on title to have title available in the index, but like you might want to do something maybe like a filtered index with post type ID equals 1, or and have that in your query so that you're only looking for questions because answers can't have titles. But beyond the scope of what we're talking about a little bit, but you might have a similar situation with some somewhat denormalized results in there. So when it comes to data types and store procedures, these are definitely things you want to keep an eye out for, whether they are completely mismatched data types or whether they are just string like max data types in there. Fixing small things can have a lot of big effects, right? Like SQL Server can just suddenly do a whole bunch of stuff better. I would be especially careful about accidental max data types if you are hoping for good performance out of column store or batch mode query plans, because that sort of deep data problem can really screw up which operators can get or use batch mode effectively. I've seen a lot of problems with that in queries that I've been tuning lately, where some column that didn't need to be a max data type is a max data type, and like batch mode on row store, you still get like a row mode like hash something for that data, for like joins to that table, and it messes everything up. Anyway, thank you for watching. I hope you enjoyed yourselves. I hope you learned a little something about data types, and I will see you in the next video, where we will talk about whatever topic number 12 is, because this is clearly topic number 11. So we still have some things on our minds, don't we? All right, cool. Thank you for watching.